The second carbohydrate, that is monosaccharide, which we are going to study in detail, is fructose. Fructose is the fruit sugar which is present in the sweet fruits like banana and mangoes. Fructose, it is having 6 carbon atoms, that is, it is also a hexose sugar, but the functional group present in fructose is ketone group, right? Therefore, this is a ketohexose. As I have said, it is present in sweet fruits, honey and vegetables. The molecular formula for fructose is C6H12O6, which is just like the glucose, but the structure of fructose is totally different than glucose. Similarly, it is having a totally different functional group, right? Fructose is also prepared by hydrolysis of sucrose, that is cane sugar, because we know when we perform the acid hydrolysis of cane sugar, that is sucrose, we got 2 products, and these are glucose and fructose. Just like glucose, let us see what is the structure of fructose. Similar to glucose, fructose can also exist in 2 forms, open structure as well as the cyclic structure. But the difference is, in case of fructose, the cyclic ring is a 5-membered ring. It forms a 5-member ring. Whereas in case of glucose, similar to glucose, let us study the structure of fructose in detail. Fructose also can exist in 2 forms, that is open structure and cyclic structure. The difference is fructose can form a 5-membered cycle, which is called as furanose, whereas in case of glucose it was pyranose, a 6-membered ring. That is the difference between structure of glucose and fructose. Therefore, the structure of fructose, it is named as fructofuranose because it is having 5-member ring, which is nothing but the furanose ring. Let us see the structure of fructose in that case, both open chain as well as the ring structure. The first structure which you are seeing on this slide, it is the open structure fructose. The first structure you are seeing on this slide, it is the open structure of the fructose. As I have told you, the functional group present in the fructose is carbonyl and not aldehyde. It is ketone functional group, right? You can see here, this is the ketone functional group present in the fructose, which is totally different from the glucose. Similarly, you can also see the penultimate carbon atom of this structure, which is on the right hand side of the structure. That means this is nothing but the D-fructose, right? Come to the cyclic structure. Similar to glucose, fructose can also form 2 types of structure, 2 types of cyclic structures. One is called as alpha, another is called as beta. Again, the difference between these alpha and beta forms is in the location or position of the hydroxyl group, right? If it is on the right hand side, it is called as alpha fructofuranose. If it is in the left hand side, it is called as beta fructofuranose. That is the basic difference between the alpha and beta forms. Similar to the glucose, the fructose, that is 2 alpha and beta forms of fructose, are also having different physical properties, just like melting points. Melting points of these 2 structures are also different, just like in case of glucose. If we want to show the furanose structure in the cyclic form, we can show as you are seeing on the slide. You can see the position of the hydroxyl group on the carbon number 2 of the alpha form. It is downwards, whereas in case of beta form, the OH group, it is upwards. That is the difference between the alpha and beta forms of the fructose, and hence we call it as fructofuranose, alpha as well as beta. That's all about the structure of fructose. So we have discussed now the detailed structures of glucose as well as fructose. For glucose, we have studied the evidences for both open structure as well as the cyclic structure. And for fructose, we have studied open structure as well as cyclic, alpha as well as beta forms of the fructose, in which we have also shown the Harvard formula for both these structures. That's all about the fructose and glucose.